So, welcome everyone. This is the IoT Academy Meetup. Thanks for joining, and today we will take you through the story of Kafka. So we dive a little bit more into technique, and therefore, actually, my first question to you is, what is your experience with Kafka? For answering this poll, please go to the QR code in the bottom corner or to Slido to answer this question. For this meetup, we invited Klarrio. This is our partner for already 5 years, and recently we passed the 100th sprint together with them, developing on our platform, the KPN Data Services Hub. Collectively, the Klarrio team has more than 200 years hands-on experience in implementing solutions at scale, on large scale, on real-time data, leveraging state-of-the-art technology, cloud native, and primarily open source techniques. KPN has been working with Klarrio for the past 5 years, as I said, and where Klarrio helped us developing on our platform, the KPN Data Services Hub. Today, for this presentation from Klarrio's side, Bruno de Bus, as the CTO of Klarrio, will join us together with Joni van der Tale. He's the marketing director and product manager. So welcome, Joni.
Thank you, Sven. Thank you for having us.
I see that meanwhile some people answered the question. So what's their experience? By far the most say, I'm blank, teach me what is Kafka. Well, I think we will touch that topic definitely during your presentation. And also a large part, 1/3, is using it in their daily work. So I think for both groups, a lot of stuff to learn today. So the floor is yours.
Thank you, Sven. Thank you very much. Very happy to be here. First of all, I will be doing most, if not all of the talking. And Bruno is primarily here to make sure I don't say anything stupid. Which he's very well aware that I'm capable of doing. Now, before I start my actual presentation, I do want to introduce Klarrio to our audience. And I typically do this by presenting our company in numbers. Because for a relatively small company, we do have the numbers to back up our claims. We have around 66 employees worldwide in 4 locations around the world, allowing us to provide support to our customers by using the follow the sun principle. And that way, there is always a Klarrio engineer awake somewhere to help our customers. As you mentioned already, with over 200 years of hands-on experience, including Kafka, which is the topic of today, which was open sourced in 2011, and we've actually been using it since 2012, but also with over 3 million devices connected to platforms that we built. Aside from that, we also average around 375 Git commits on a weekly basis, which shows a very active development cycle. But what's really impressive, that's the amount of data that we process. Now, even by one of our platforms, in 2020 alone, we processed over 3 petabytes of data. And oh yeah, just to be clear, the person in the picture here is not a Klarrio employee. But I just like using this picture because I still have fond memories of this. And I still remember seeing this picture of Microsoft's Bill Gates promoting the CD-ROM. Now, I hope people here still know what a CD-ROM is. But they promoted this in 1994 with the attached picture. And what they said was, one CD-ROM that is holding here can hold more information than all of the paper that's below him. That's over 300,000 sheets of paper. So these 2 towers are estimated at around 13 meters high. And I wanted to put this in perspective. So if we would do the exact same thing, but this time actually replace the sheets of paper with these CD-ROMs to illustrate 3 petabytes, the stack of CD-ROMs would be 5.4 kilometers high, with Bill sitting on top of it. When I started thinking about these numbers, this was absolutely mind-boggling to me. But it does explain why it's called big data. Now, I do want to quickly highlight the concept of streaming data because it feeds into the rest of my presentation. And streaming data is just a matter of time. I'm not going to say that we created the graph that we're seeing here, but it does represent what we strongly believe in. And that's the concept of data losing value over time. This means, as you can see in the graph, the faster you react to your data changing, the more impact it makes. And that's why in a streaming world, you're mostly acting on data that's at most a couple of minutes old. Now, it's easy to understand that if two companies who are competing with each other and have access to the exact same data, that the company who takes action on their data will most likely win the race. And as the graph illustrates, there's still value to be found in older data. It can be of great value to train your analytics models, for instance. Just to clarify, while I did just say the sub-minute mark, I also mean that real time can translate into stuff like an hour later or a day later. What do I mean by that? For instance, reactions to marketing campaigns. In the past, where you typically did a marketing campaign for 1 month, and then at the end of that month, you would evaluate your campaign and see how it was going and then tweaking. We can do that evaluation today in the minute mark, which means think about YouTube videos where you see that commercial. You can have insights in how your marketing campaign is happening in real time. But also think about industrial processes where you can tune your production lines based on real-time market demand. And other business processes as well, such as company stocks or maybe even movements in the markets. And by adhering to that mindset of data losing value over time, we at Klarrio have adopted to working with primarily open source streaming technologies, of which Kafka is currently the most popular choice. Now, what was the idea behind this presentation then? It's to try and make Kafka understandable based on the experience that I personally had when I started working in a company full of experts. When I first started out with Klarrio, I had no clue what Kafka was and what it did. I knew it had something to do with cloud technology, that it was a distributed system, that there was something around publish subscribe, but that was about it. It took me close to a year just to understand what it is and what it's used for. Now, that could be me. I do have a technical background, but I still found it difficult to grasp some of the concepts. So when KPN asked us to present Kafka, the working title, which was a quote from a CIO of a big Dutch company, was, and please do excuse my language, I'm quoting here, Kafka is a bitch. So while I don't agree with that statement, I did understand where he was coming from. So I saw my chance to try and create something that could be easily understandable by people with different skill sets and experiences, hoping to reduce the time required to understand it. Now, this presentation will be a bit of a mix between what is Kafka and what is managing Kafka. So when I started my journey, I started doing some research. And when I mentioned the working title of Kafka is a bitch to our engineers, the first reaction I had from them was, she's not a bitch once you get to know her. So I tried to get to know her. And I did what I always do. I started Googling and I started researching Kafka. And I don't know about you, but I typically start with Wikipedia. And while I do generally consider this to be an amazing resource, it didn't really explain it to me. Now, at this point, when I'm a bit more familiar with Kafka, there's nothing wrong with the explanation that we're seeing here. But if you're new to Kafka, it can be hard to understand. So my next step was to start researching companies that actually use Kafka. So I researched a lot, and it turns out a lot of companies actually use Kafka. And a lot of them are also part of the Fortune 100. According to the Kafka website, over 80% of companies in the Fortune 100 use Kafka on a daily basis. So how do they use it? Apparently for multiple different use cases. So LinkedIn originally developed Kafka and is still using it for their activity stream data and operational metrics. And it powers a number of their products in addition to their offline analytics systems. Something closer to home, Rabobank, for instance, one of the three largest banks in the Netherlands, at its digital nervous system, what they call the business event bus, it's powered by Apache Kafka. And it's used by an increasing amount of financial processes and services in real time, which, as you can imagine, is very important in financial trading, for example. You already know or also know Airbnb. They use Kafka in their event pipeline and their exception tracking. They've also announced that they're going to use Kafka for a lot more in the future. Another example that we have is the New York Times, who uses Apache Kafka to store, distribute their published content to various applications and systems that make it available to their readers. What Bruno also told me was that they also use Kafka as their single source of truth, which is pretty cool to hear. Then we also have the Netflix, who uses Kafka for real-time monitoring and their event processing pipeline. They're very open about this. They blog about it on their tech blog a lot. And when I was doing my research in their 2016 post, they mentioned that their current pipeline at that time was processing approximately 500 billion events per day, which equates to approximately 1.3 petabytes per day. So I thought I was boasting with our 3 petabytes on a single platform before, but Netflix in 2016 was already processing 1.3 petabytes per day. We can only imagine what their numbers look like now during all of this pandemic binge watching that's going on. And these are just a few of the use cases that it's used for. Okay, but that still doesn't entirely explain what it actually is. So in my research, I started looking into some analogies to better understand it. The best two I could find were about books and about bread. It definitely helped, and I do recommend checking out these explanations. I've provided the links here, and as they did clarify a few elements for me, I wasn't quite there yet. There's also one about an airplane, but I'll come back to that one later. It would be impossible for me to explain in the time that we have here available today what I've learned in this past year. So I will stick to the absolute basics. You have multiple producers of data and you have multiple consumers. They can connect to Kafka, allowing producers to send data to Kafka by putting it on a topic. Now, the concept of topic, that's relatively straightforward. You put weather data on a topic called weather, for instance. Makes sense. Consumers can then read that data and do something with it. Could be any number of things. For instance, on this example of a weather topic, consumer one could be a web application visualizing the data. Consumer two could be an analytics engine making improved weather predictions. Consumer three could be a database sync, reading in the data for long-term storage, and so on. Now, do bear in mind that this is an extreme oversimplification, but with these concepts in mind, the rest of the presentation will hopefully be a bit more clear. In addition to that, with an audience like this, with an IoT interest, I might hear some of you thinking, this sounds a lot like something I already know, MQTT. So how does MQTT compare to Kafka? Well, if I do a quick Google search and I take one of the first images that pops up when searching for MQTT, I get this. Now, I assume this looks quite familiar. Let me make it a bit easier on you. As you can see, it looks very much the same. The core concepts are also generally the same. So how do they relate to each other? Well, most of you here will have heard, worked, or at least played with MQTT before. We heard that in the poll in the beginning as well. So I won't go into too much detail, but I do want to highlight some differences between the two. MQTT was built for IoT use cases, but not for data integration and data processing. Apache Kafka is not an IoT platform, but it is an event streaming platform. And while I was preparing this presentation, during my research, I also saw that Kai Weiner did a 5-part series on Apache Kafka and MQTT. And I used this as part of my research project. And I highly recommend this possibly as a follow-up to this session. So is it MQTT versus Kafka then? Well, not really. They don't really compete with each other, but rather complement each other. They both have their strengths and their weaknesses. And we also, in almost all of our platform builds, we combine the two. Now, be sure to check out the Kafka Summit presentation on this done by our head architect, Dominique, where he goes into much more technical detail on how these two technologies complement each other. Now, I ask myself the question, okay, these are the differences, but when do I use what? And again, there the answer is also straightforward. If you have a long latency network with large amounts of clients and some distance between your components, such as your IoT devices at your home, who will only produce and consume small amount of data individually, and you need something lightweight, you go for MQTT. For internal messaging, data integration, where you have few producers or few consumers, but each of those have large amounts of data, as well as you want them to be operating in close proximity to the brokers. I know I'm getting a bit technical here, but what you basically want to do is having your data processed close to where your data is for low latency. You use Kafka. And I mentioned as well that I wanted to give you a few guidelines that can help. So if you have a lot of topics, like more than 100K, more than 100,000, you use MQTT. If you have a lot of producers, you also use MQTT. Now, if you have a lot of messages per consumer or producer, you use Kafka. So the sweet spot is somewhere in between. But as I mentioned, they do complement each other. So in many IoT use cases, the architecture combines both technologies by using MQTT for IoT connectivity and Kafka for large-scale backend processing of the data that is sent to and from those thousands of IoT devices. So at this point, I had an idea when to use what technology, and I hope you do too, up until here. But it still didn't fully explain Kafka to me. So I started talking to our head architect, Dominique. And it's finally started clicking in my head when I discussed this with him. And he has the capability of explaining things so they make sense to me. And he made another analogy, the analogy of the jet plane, which I referenced earlier. He said, Joni, Kafka is a jet engine, which offers incredible speed and can take you anywhere in the world, but with only an engine, you won't get very far. Now, the funny thing to me here is that while most people would use an analogy to explain how a jet engine works, Dominique uses a jet engine to explain how something else works. So he said, for the sake of argument, let's say that you've been given a jet engine, a naked Kafka. And he said that because just spinning up a Kafka cluster is relatively easy. What's hard, however, is that everything that surrounds that jet engine, the plane itself. Now, in order to use that plane, you will need a ton of infrastructure. You will need well-trained personnel to build, operate, maintain, guide, secure, or even a pilot who can fly and land the plane, you need the necessary security measures or onboarding processes or quality assurance mechanisms. So there's a lot that you need that's around the engine. So how does that translate to real life? Well, when you're a big company like the ones I mentioned, you can afford to have a private jet engine all to yourself. But if you're like me, or you're just starting out, or you don't have the experience, instead of building the plane, you buy a boarding pass, you buy a ticket. You have someone else do all the difficult stuff for you. Now, don't get me wrong here. This doesn't necessarily mean it's a bad thing. Maybe I don't want a private jet. Well, I do, but that's besides the point. Maybe I just want to get from point A to point B. So, how do we get to point B then? So, I'm going to continue with this analogy, trying to explain the four options that you have. You can build the engine and do it yourself, or have someone set it up for you, like that's what Klarrio does under the build, operate, transfer model, where we build it for our customers, we operate it for a while, we do some hand holding, we slowly ease our customers into using it, and subsequently we transfer the knowledge to our customers so that they regain control of their core systems. Now, the second option you have is you can also go for part of the plane through Kafka as a service offerings. Or you can go for the full plane, but you won't have a pilot. This is typically what's offered by cloud providers, but the number of providers keeps increasing. And you also have topic as a service, which is another option where you buy a ticket and you pay per seat. A lot of it is managed for you. There's not much you have left to do, but as the icon here aptly suggests, it might be a middle seat experience, which limits your options. Finally, you have the first class ticket, where everything is handled for you, which extends the capabilities with useful functionalities. It's a plane, but there is much more you can do. In this case, for example, we have the KPN's DSH, which I will explain in more detail later. So hang tight on that. Now, all of these options have pros and cons. Option 1 will give you more control over your future, but comes with a steep learning curve and multiple integrations that will have to be made by yourself or your partner. Option 2 will, in our experience, only solve part of your problem. And I will come back to why in the next slide. Option 3 and 4 will offer ease of use, but do be mindful of vendor lock-in. But those vendor lock-in effects can be minimized as much as possible. The trick here is really to find a partner that you can work with. Now, whatever option you choose, whether doing it yourself, having it done for you, or taking a managed service, I do want to provide some information on the pitfalls you may encounter when making your decision. Typically, you will very quickly end up with cloud providers or industry leaders, some offerings being better than others. And what you will often see is promises of reducing complexity, improving scalability, and unburdening yourself. What we as Klarrio have unfortunately seen happening time and time again is that this is not always the case. Solutions will often not be cheap or will sometimes force you to do things suboptimally, such as doing your processing off platform, which can cause latency impacts and additional data transmission costs. So a couple of things to look out for when working with Kafka is that there isn't really any protection against badly behaving consumers and producers, specifically not within your own organization. So one producer or consumer can take down your entire cluster. In addition to that, the concepts of users are very vague within Kafka. Permissions are not there with an off-the-shelf managed Kafka, And cloud providers claim you can fix the users and permissions issue with their AIM solutions or authentication and identity management solutions. But in our experience, this is rarely the case. In addition to that, you get a toolbox to manage your security, but it isn't managed. You basically get a big box of Lego bricks, which you still have to put together and still have to build yourself. Another item is off-the-shelf solutions typically are not very opinionated. What does that mean? Well, everyone tells you how you can do things. They provide you with a lot of technical documentation, but no one tells you how you should do things, which can make things very difficult in the beginning. In the case of combining MQTT and Kafka, which I mentioned earlier, managed service providers do offer this, but it's always on the premise of sending data from devices to the cloud, not the other way around. And finally, sometimes your use cases have specific requirements, such as example, latency, which cannot be easily enforced in the offerings that are available today. So a prime example of this, so I want to highlight a few of these items, was the Talking Traffic project, which was run by KPN. We had the requirements of having 2.5 million cars on the road that all had to be able to consume data. If you would have done this on a cloud platform with a managed service, it would have been extremely expensive. Another example that we have is that you have latency requirements, such as round trip time. Again, in this Talking Traffic initiative, where you would want to get all of the data from the mobility in the Netherlands, you had a use case which allowed priority vehicles such as ambulances, fire trucks, or police cars to request priority green light at traffic intersections. Now, as you can imagine, if your processing time is too high for your priority request to be sent to the cloud, be processed, sent to the intersection, then your priority vehicle will have passed the intersection already before getting the green light. So all of this does feed into the fact that a managed service might not fit all use cases. There's no such thing as a one solution fits all. So now I don't want to sound too commercial here, but I do want to highlight the Data Services Hub, because we've been kindly invited here by KPN, and we're also very proud of what we've been able to accomplish with them by helping them build the KPN Data Services Hub. And the reason why I want to do this is because most of the differentiating features, some of which I just mentioned, are a result of missing functionality that cannot be found in the market today. KPN needed a streaming platform with multi-tenant capabilities internally for different departments within the organization, or externally for a number of different customers. Now, there was also a need for controlled sharing of data between multiple tenants, something that is difficult, if not impossible, to accomplish on offerings found in the market today. The last thing they needed was a kick-ass MQTT bridge that was also capable of scaling in egress use cases, which meant that, again, with the Talking Traffic use case, we had to be capable of 2.5 million connected cars, each publishing their location every second. And each one of those cars receiving 4 messages back every second. Some quick calculations teach us that that averages about 12.5 million messages per second going back and forth. Now, to put this in perspective, 5 years ago, there wasn't even a managed Kafka solution available, let alone have all of the aforementioned requirements. And it wouldn't make much sense to talk about stuff everyone else has, right? So I do want to talk about the differentiating features. The DSH offers multi-tenancy, where you get access to a Kafka cluster. So you have your event streaming platform and any additional services available. such as deploying your own containers, all to bootstrap yourself into using Kafka, while maintaining isolation from everyone else on the platform on both security and performance level. DSH is also very opinionated. Now, some people might argue that this reduces the flexibility, but it actually makes things a lot easier. The difficult decisions have already been made for you, such as how do you connect all of these elements together, or how do you do your security. Data sharing with other companies is also possible. So the DSH allows different companies to share their data and work together. Even direct competitors. We've actually had direct competitors sharing their data and each building their own individual use cases with a combined data set. The platform is also security tested on a regular basis by KPN and CISO, whom are well renowned for their testing practices, but also by external parties. And on the topic of scalability, being Kafka based, it offers a lot of scalability options. And last but not least, you also have a lot of customization that has already been done, which together with the fact that the data services hub is opinionated, allows for a very good user experience. Now, that's enough of me talking. I would like to show you a few demonstrations of some of the use cases that we've worked on or are working on. And I first want to start, I want to show you a bit more on a business intelligence use case. Then I would like to go to a marketing or strategy use case, and finally show something most relevant for this audience, an IoT use case, which I've mentioned quite a few times already, which is the talking traffic. So let me switch over to a different screen.
Yoni, meanwhile, you're loading the screen. I want to point the audience to the place where they can ask questions. So please, in the bottom of the screen, there will be pop up a QR code you can scan, so you can ask your questions there, and I will see them and bring them to Yoni at the end of this presentation. So please continue.
Thank you, Sven. So as I mentioned, a business intelligence use case. What I'm showing here is streaming key performance indicators. So as you can imagine, a C-level executive can dream of a dashboard like this. In one instance, he basically has an entire overview of how his company is doing. He has information about the revenue. He has information about the sales. Is he losing customers? Is he gaining customers? In the case of if he has a call center, he can immediately see how his call center is doing. You can also, of course, visualize public data such as stock market prices and things like that. But he has an immediate overview of what is happening in his company. Now, I can assure you that this is a dream of a lot of C-level executives to get an overview like this, and having this in real time is even better. What I also want to highlight is the middle part here, the social media, Twitter, where you also have marketing capabilities, where in this case you can compare your own product, see in social media how your product is doing compared to your competitor's product, and really how it's being received by the public. And as I mentioned, this is a KPI, this is business intelligence. You can also use it for social media, for market research. So I also wanted to show you the fake news analysis or analytics platform. Why? Because in this particular use case, what we did here, and that's again showing the amount of data that is capable of being processed. In this use case, we ingested over 75 million websites in 115 different languages to analyze how a particular party is perceived by the general public. What do I mean by this? You've heard the term fake news mentioned quite a lot, I assume, but it's an actual thing. There's a lot of fake news going on. And at one point, we did something with NATO where they wanted to have an idea of how are we perceived by the public. Because there's a lot of fake news still today. I'm sure you've seen it on your social media channels as well. So how do, in the case of fake news analytics, how does a particular topic which is published by NATO, or for instance, just making examples here by Russia, how is it picked up by neutral media, for instance? And this is all possible to do this type of analytics and make sure that you have insights. You can focus how your marketing strategy should work and how you're perceived by the general public. So that's my second demo. Now I want to come to, I think, what's going to be most relevant for most of the people here, which is the talking traffic demo, which is a good example of let's call it an IoT use case, where when KPN did this, so as I mentioned earlier, the goal was to get all of the mobility data from the Netherlands, and we do that here. And this is just a visualization of that data. So what we're seeing here on the screen is all of the different coils that are underneath the roads, which if we click on these, we can actually see how fast cars are going on those particular roads. So we get a very good indication if there's traffic jams or how fluid traffic is going. So as you can see here, they're green because they're approximately the speed that they can or should drive. You also have the yellow items, which immediately gives you an idea of if there's a traffic jam or slowness in traffic. Now, I can understand some of you might be thinking, yeah, I have this in applications that I have available today, but do bear in mind that this is for the whole of the Netherlands, right? So you get all of that information in every different location. And what's very important, as you can imagine, for one particular person, not all of that data that you have for the whole of Netherlands is important. If I want to know traffic information, for me personally, I want to know what's going on around me. So what we're seeing here is what we call, or what is called quad keys, which is basically a rectangle that allows you to minimize the amount of data that you want to visualize. So you only see what's relevant to you. You have multiple different sources of data. So these are the coils underneath the road, but you could also have parking data, for instance. Also rail data, bus, tram, metro data. I can actually click these trains, and these are actual live trains. So this train is actually now driving this track. We can see that it's on time, which is incredible. I'm not surprised in the Netherlands, but we're not used to that in Belgium. You also have the information on all of the different, you guys can be late as well. Anyway, early, 246 seconds early. So you have that information on the buses, the metro, all of that as well. So, we have one that's late. At least we have one. You also have information such as weather, air pollution, maybe even bicycle parking locations. Very important in the Netherlands. We have public transport, but you can even do other stuff. So it's just your imagination that is the limiting factor here. So we also did something like, okay, let's visualize where these satellites are. So these are actually in orbit in that location. You can actually see which satellites they are, which is, pretty cool to me. And you see all of the different weather information or what the pollution levels are like. So you have a lot of information, a lot of this data can be shown, can be visualized, but I think still one level higher that I like even more is the fact that we can visualize the actual traffic intersections. You can show as you can see here, the lights, how they are at this stage. So you can see, if I go into more detail, let me open a detailed view. So I need to log back in. Of course, security, very important. What we see here is we see one intersection. And as you can see, this is the actual status, how this intersection, so this Hobelmanstraat in I think close to Eindhoven, is actually performing right now. So we see that a number of the lanes have a red light, but you can also see, so the data is still loading a little bit. It's my browser here that is showing this, but you can also, it starts getting even more cool when I start to zoom out, because that allows you to actually see multiple intersections and really see where the green flows are. You can have an actual visualization of how your traffic is acting in real time. So I know I'm excited about this. I think this is very cool. I think it visualizes very well the amount of data that is being ingested, processed, and then visualized. So I did want to make sure that I showed you this one. I have one more.
So
That is,
Yoni,
yeah, yeah,
before you continue, looking at this, we are looking at the visualization of the data that we basically, yeah, let's say consume.
yeah.
What if I want to, well, we talked in the beginning of the presentation about acting on the data. What if I want to act on this data? How does it work with Kafka or with the platform below this?
So there's multiple different ways of actually interacting with this. What we're seeing here, the visualization itself is is acting upon that data, right? Because this is purely for demonstration purposes. This data is actually used by a number of different operators on the platform that can actually build real life use cases with it that can actually be monetized. So it's very important to make sure that you get all of your data in a single location, and the more data you have, the more interesting things you can do.
All right, thanks.
So one additional thing that I wanted to show you as well is an example of and I do need to run a small replay on that data because we don't have an actual car driving at this moment. But in one of the use cases, we also did an autonomous driving exercise. So you could actually, as you can envision, most of you will have heard what Uber is doing and self-driving cars and all of these things. But we're doing that in the Netherlands as well. What we're seeing here is a visualization of an autonomous driving car. And you're actually visualizing how this car is driving in real time on the road. Which, I mean, to us, this is incredible. It gives you a very good understanding, a real life, actual situation of what's going on in the field. So these are the demonstrations that I wanted to do for sure. And I also wanted to very quickly continue or summarize at the very least what we've just seen here. So at the beginning of my presentation, I did mention the CIO who said managing Kafka is a bitch. Now, what did he mean by this? Is it hard to run Kafka? Not according to our engineers. It takes 5 minutes to set up and run. But multi-tenancy, scalability, customization, your security requirements, that's really what's the difficult part. Now, I've also talked about the analogy with the airplane. So do I need to build an airplane, or do I need to buy a ticket? While buying your ticket will most likely suffice for most small to medium businesses, starting your Kafka journey from scratch can be extremely daunting. So we recommend surrounding yourself with knowledgeable partners and try to avoid vendor lock-in as much as possible. So our advice is to begin with buying a ticket before operating your own airplane and educating yourself in that context. Now, with that said, if you do need a platform where you have multiple parties or departments or even competitors that can share data, where there our needs for the necessary security to make sure that everyone is in charge of their own data, and very important in the context of a plane, you want first-class treatment, then I can only say be sure to contact KPN about the data services hub. You can do that through the QR code that you see on the screen here on the slide, or on the link below. And then finally, I do wanted to thank you, Sven. I wanted to thank KPN, Bruno and Dominique at Klarrio, but also all of the Klarrio engineers, everyone that helped with creating this presentation. I want to thank the IoT Academy for hosting us. And I'm happy to continue the discussion or the conversation here. I have Bruno with me, so feel free to connect with me through the LinkedIn, through the QR code. And if you have any questions, suggestions, comments, I'm very happy to discuss.
Right. Thanks a lot, Joni. A lot I've learned also, although we already work for a while together. I'm just told that on the page you can also find the contact information. Am I saying that right, Jurjen? Yes. Yeah, various ways to contact us if you have any interesting use cases or more questions after what have been told today. Still, you can ask your question via the QR code if you have any. But I have one question for now, Jon. You've talked about a lot about, yeah, Kafka being the way to build solutions at very large scale, thousands, petabytes. I've heard big numbers, but when do I have to start thinking about it at the lower level, let's say?
That is a very good question. Well, as I do mention, there is kind of a sweet spot for Kafka usage. So if you have a limited number of producers or consumers that each produce or consume large amounts of data, you really have no other choice than at this stage to go for Kafka. But you will always need technologies such as MQTT to get that data to and from the cloud to be processed.
Yeah. Clear. Okay, so if I maybe I start small, but I know that I will scale. Begin with Kafka is the takeaway from that.
Yeah,
I know.
definitely.
Yeah, we discussed also. This is a IoT Academy and IoT community, but you showed some nice examples of other use cases. I was curious, can you name some examples of, for example, the case with data integration or data processing?
Yeah, sure. So you're absolutely right. So in addition to the use cases, the ones from the Fortune 100 that I already mentioned, who are using Kafka, there's even more possibilities. So as long as there's large volumes of data that need to be processed, you really can't go wrong with Kafka. A couple of examples are the SIEM use cases, so security incident and event management, which is also typically processed using Kafka, where you really need to be able to react very quickly to events. Of course, analytics, very important, where you want to do different use cases, where you want to do analysis on data that is coming in. There's definitely IoT use cases. Those are probably used the most in Kafka, but there's so much more to be done there.
Any case where you want to respond fast on
Exactly.
a lot of data. Yeah, clear. Thanks. I see a question coming in related to the airplane analogy. What are the restrictions if I only have a ticket? Are there any? So yeah, what are I translated, what are my limits if I only buy the ticket instead of having the whole plane?
Well, as I mentioned earlier, all of these items have their pros and cons. If you only buy a ticket, then you're of course maybe a bit limited in your capabilities. You don't have that much freedom. You run the risk of getting into a vendor lock-in situation. But what we see is if you buy that ticket, you do give yourself the opportunity to learn to use that.
Yeah.
And it's very important to make sure that when you use that ticket, even though there are limitations, most of those limitations are put in place to make things easier on you.
Right. For a reason. Yeah. For
Yeah,
a good reason. Yeah. You mentioned
exactly.
security, that kind of stuff. Yeah. Yeah.
Yeah, making sure that when sharing infrastructure, for instance, or you want to make sure that, for instance, if you have multiple tenants on the same platform, you don't want those tenants to be interfering with each other. You also need to know when something goes wrong,
Yeah.
where those issues originated. So all of these items are available within those
Yeah.
platforms.
Clear. So I think I will start with a ticket instead of a private plane. Although I think that's a nice point on the horizon, as they call it. I think that's it. I don't see any other questions coming in, so let's round it up. Thanks a lot, Joni and Bruno, for joining, and yeah, I hope to see you guys soon in real life again. And well, thanks for the audience for joining this meetup. If I'm right, you can see it or replay it, share it with colleagues who missed it afterwards because it will be published. And yeah, feel free to contact us if you have any use cases or questions after this. Yoni or I or any of our team colleagues are happy to answer them. Thanks a lot, and that's it.
Thank you.
Thanks. Bye.
Bye bye.